Hello, in this video we are going to do chapter 1.3 part 1 of trig functions. So in this video we'll talk about how we can evaluate trig function, maybe solve trig equation and go through some identities. So what is a trig function? So there's 6 trig functions, basic trig functions. They are periodic function that are defined by the unit circle with a domain in radians of all real numbers. So when we think about trig function, we think of angles and degrees. But if our input is in radians, then it doesn't have to be in angles. Radian has no units, so it can be used to model anything. So to convert between degrees and radians, we would use the unit vector conversion, the 2 ratio pi over 180, because in terms of radian, a half of a circle is pi radian, and half of a circle is 180 degree, or a straight line is 180 degrees, so they're equivalent. So an example would be if I want to convert 270, let me do the pen first. If I want to convert 270 into radians, this is in degrees with a 0 here. That means it's in degree. So I would do 270 times, I want a degree, so I want to divide 180 degree. So I can cancel it and pi in the top. So if you multiply them, this would be cancel as 2 divided by 90. This is 3. So it's 3 pi over 2 for exact value in radian. What about if I have 6 pi over 5? I want to convert it into degree. So I would do 6 pi over 5 times, I want it to be degree, so my degree would be in the top, and my pi is here. So you cancel all these, and then you multiply, cancel 180 divided by 5 would be 36. So it's become 36 times 6 degree, which is 216 degree. Okay, so that's how you can convert between radian and degree. In reality, when we use trig function, we mostly use radian. We almost never use degree, but it's good to know that they correspond to degree, so you can know where it is located in the unit circle. So this is a unit circle, a smaller one in the notes. That's document how you can find trig function of sine and cosine values by looking at the coordinate of where the angles intercept the unit circle. So in general, we would have a point, we have an angle, theta or x here, and then this is the terminal side of that angle. They intersect with the unit circle at this point, x, y. It is using this 2 number that we would generate all the unit circle. So this is the point P, that is the part that on the terminal side of the angles. So how do we define them? Oh, and then if they are special angles like 30 degree, pi over 6, pi over 4, pi over 3, then the x, y are well defined in particular numbers. So you do not need to use calculator to approximate them. So for special angles such as these that is specified in the unit circle, this is what you get for to give for when you evaluate sine, cosine, and all the others one. So how are the 6 trig function defined? So thinking of this point x, y on the unit circle, sine theta is y, cosine theta is x. So that means anything that is on the unit circle, the x, y, the first number x is always cosine of that angle, and the y coordinate is sine of that angle. Okay, so that is sine and cosine. And tangent would be a ratio of y over x, the ratio of sine over cosine. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, cotangent is the ratio of x over y, and all these ratio things, it would be undefined if the denominator is 0. So it's only defined when they are not 0. So that's the first definition of how you would evaluate a trig function for radian of all real number. But when the angle is between from 0 to 90 degrees, the definitions can be related to a ratio of a right triangle, SOHCAHTOA, right? So how do we do it? So we would say, let me select the pen. We would say if the angle is here and the right triangle, the side that's opposite to the right triangle is called the opposite. The side adjacent to it is adjacent, and then the hypotenuse is h. So SOHCAHTOA. So you write this out, it would tell you how it is defined. Sine theta is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And the secant, cosecant, and cotangent are respectively the reciprocal of sine, cosine. In this case, all these values are positive. They never had a negative value, so we don't have to consider undefined situation. And the theta that we're talking about is between 0 to 90 degrees though. Okay. And then out of the relationship between sine and cosine, because sine and cosine are on a unit circle, we have these identities. These are called Pythagorean identities. For any angle, sine squared theta plus cosine squared theta is 1. 1 plus tangent squared theta is secant, and 1 plus cotangent squared theta is cosecant squared. These are really important trig identities that we use for solving equation, for actually in the future manipulating calculus expression. And then there is these two double angle identities that is useful. There's tons of trig identities available, that is defined already, but these two or these sets are kind of the most important ones. So you need to remember them. I know you can use, because in online learning these are open books, so you know them, but you need to know that, oh, if I see sine 2 theta, I can decompose it in like this. If I see cosine 2 theta, I can have a choice. I have a choices of 3 identities that I can change it into. They are very useful in solving equation. So whenever we study any function, the things that we want to do is to evaluate the function, of course, and also to, especially the exact values in calculus. We don't want to just use calculator to do it. And also solve equation as well as graphing. And then the last one would be application. So in this particular video, we'll look at how we evaluate a particular trig function. So these are limited example only. There are a lot of worksheets a lot of other problems that I have set in the class worksheet that you should do. If you are not very familiar with the unit circle, you should, because the unit circle is kind of like the multiplication table for grade school kid. You need to be able to record it right from your memory, even though you can look at it, but I recommend you to get yourself familiarized with it. So evaluating some trig function value. So sine 5 pi over 3. Of course, we have to look at the unit circle, but where is 5 pi over 3? So I have a unit circle that I open up here. Sine 5 pi over 3 is related to pi over 3, but it is on here on the fourth quadrant, 5 pi over 3, and I want sine, right? 5 pi over 3 sine is y, so it's negative with 3 over 2. We want to have the exact value. Do not use the this one. Do not use the calculator to find them. Negative with 3 over 2. Okay. What about cosecant 3 pi over 2? Well, cosecant is not in the unit circle, so we have to relate it back to the sine and cosine. So it's the reciprocal of sine, 3 pi over 2. So where's 3 pi over 2 in a unit circle? So maybe I'll draw it here instead of looking at 3 pi over 2 is here. So what is the x and y coordinate? This is 0, negative 1, right? 0, negative 1. So sine 3 pi over 2 is the y coordinate. So it's 1 over -1 is still -1. So that's how you do it. So yeah, you should practice more of these. The second set of questions that we want to go through is, this is very useful in calculus, especially in chapter 3, chapter 4. You see that you need to know how to do these a lot. Is to solve the equation that involve a trig function. Usually we would use whatever that we use for algebraic expression to solve for sine or cosine or whatever trig function that we have. And then we will use reverse lookup in the unit circle to figure out what theta corresponds to those values. So let's look at this. 2 sine squared theta minus 1 equal to 0. So there's a square here. It's quadratic. So I am going to use square root method. 1 over 2, right? And then I would say I'm going to take square root on both sides. So it would be plus and minus square root of 1 over 2. That is the same as root 2 over 2. Right? Plus and minus. Remember the plus and minus. When you do the square root, this side you have to do the plus and minus. Okay. So that means I have sine theta equal to this. So what theta would it be so that sine theta is equal to positive root 2 over 2 or negative root 2 over 2. So you're going to do a reverse lookup in the unit circle. So where would these be so that the y coordinate is root 2 over 2 or negative root 2 over 2? We figured that it's all actually in these 4 places. Because these are root 2 over 2 and root 2 over 2 for pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So the answer would be pi over 4. You kind of do reverse lookup. Look at the y value that matches this, and the answer is the theta. 3 pi over 4, 5 pi over 4, and 7 pi over 4. For x between, well, actually it should be theta. For theta between 0 to 2 pi. So that's the first one. The second one is cosine squared 2 theta equal to cosine theta. Okay. We cannot cancel theta because this is 2 theta. So what we can do is we're going to use a units, identities to change it into a function that involves cosine theta. So cosine, it should not be a square. It should be cosine 2 theta. It's a typo here. So cosine 2 theta is cosine square theta minus 1. Okay, to solve this, we know that this is again a quadratic. So cosine square 2 theta minus cosine theta minus 1 equal to 0. So we would factor this as 2 cosine theta. You can use trial and error to factor. What would this be? Is it a plus 1 or minus 1? This is a minus 1. This is a plus 1 because after that, then you have a negative cosine theta. And then equal to 0. And then we split it into 2. Okay, so this would be 2 cosine theta equal to negative 1, meaning cosine theta equal to negative 1/2. Now you look at the unit circle. Where in the unit circle where your cosine is x, your x value is negative 1/2. Now cosine is negative 1/2 in quadrant 2 and 3. So if you look at the unit circle, this is where you have a negative 1/2 in the x coordinate. So, and what is this? What are these? So we can go back to this one to look at. What are these? So you see how there is a negative 1/2 here and a negative 1/2 here. And it's 2 pi over 3 and 4 pi over 3. So our answer here would be 2 pi over 3 and 4 pi over 3. That's the first one. The other one would be cosine theta equal to 1. right? So where is cosine theta equal to 1? So look back at the unit circle. Where's my x is equal to 1? So it's only here, right? Only